With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, let us start with our question. In this question, what is given that which of the following statement related to the this hysteresis loop is incorrect? We need to find which is the incorrect statement. Okay. Now, first of all, we can just draw because each of the statement is related with our this BH curve. So first of all, we can just draw our BH curve. Okay. So it would be the curve. This curve would be our this magnetic flux density versus our magnetizing field curve. So this, let's say this is our B axis and this is our H axis. Okay, we just write here this is our H, or the externally applied this magnetizing field, and this is our B, the magnetic flux density. Now, so hysteresis curve look like this. So it would be going like this, and then this would be the, basically this would be our loop. Okay, this would be our loop. Now there are some pertinent points in this. So one of the point is this point, one of the point is this point. Okay, so this correspond when our this magnetic field, okay, it turns out to 0, but on in the opposite this direction of the magnetizing field. Okay, so if we just first of all, if we from this point, if we are just taking, if we are changing the direction of the magnetizing field, okay, so there would be an instant when magnetizing field, external magnetizing field would be equals to 0, but still there would be some our magnetic flux density which would be held in the specimen. Now this value would correspond to our, this value would be corresponding to our retentivity. Okay. So and this point, when we have seen that this our magnetic flux density here, it becomes 0 on the application of a negative external field. So this would be our coercivity, we just denoted by C. Now this is the area of the loop. Okay, so area of the loop would be representing the energy which is dissipated in the on applying the external magnetic field. Now if we see for the first part, the curve of B against H for a magnetic this magnetic material is called magnetic loop. Sorry, hysteresis loop. This is correct. Okay, this is the general statement, but we need to find the incorrect one. So this cannot be the option. The area of the BH is a measure of power dissipated per cycle per unit area of the specimen. Now this statement is wrong. Okay, so it is not a measure of the power, but it is a measure of the amount of the energy which is lost in applying the external magnetic field. So this statement is the incorrect statement. So this would be our correct option. Now in the C point, coercivity is a measure of the magnetic field required to destroy the residual magnetism or the ferromagnetic material. This is also right. So we can see that this is the coercivity. It is the amount of the external magnetic field which is to apply to just make the this magnetic flux density in a specimen to be equals to 0. That means our C statement is a correct statement. We need to find the incorrect one. Now the retentivity of a sample is a measure of the magnetizing field remaining in the sample, this specimen, when the magnetizing field is removed. Now this is also a correct statement. If you can see from the figure itself, this is what we have marked our C. Now if we see the statement, it is a measure of the magnetic field. Yes, correct. It is a measure. It is a magnetic field when the magnetizing field is removed. That means H value would be equals to 0. So this is also a correct statement. So the only incorrect statement would be our B. Hope you understood the solution. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.